All right, let's take a look at 7.93 Part D. We have lead 4 oxide going to reacting with chloride to yield lead 2 chloride and oxygen gas. One of the very confusing things about this is people become really puzzled how to balance it. I think the first thing you need to realize here is that chlorine really plays zero role in this reaction. What do I mean? Well, let's assign oxidation numbers to everything. We assign oxidation numbers to this, and we know that lead is 4 plus because it has 2 oxygens, which always has an oxidation number of 2 negative. The chloride right here has an oxidation number of -1 because it's an ion by itself. Chlorine also has a -1 over there because it's in a compound, and it's a halogen. And that gives lead a 2 plus, and the oxygen here is 0. What that means is that chlorine, or chloride rather, is a spectator ion. That's right. It has nothing to do whatsoever with this reaction. Therefore, we're going to take it out of this equation. We're just going to wipe it out of existence so that the equation's a little bit more friendly in terms of our balancing. And now here's the part of the problem that I'm not really sure how the book expects you to get. Other than, here's your chance to gain experience so that next time you see something like this, you'll recognize it. I only have 3 compounds there, and I need to write 2 half reactions. Here's what you do. You're going to write a half reaction for your lead, and your half reaction is going to go like this. You're going to say, okay, I've got lead oxide over here, and my lead oxide is going to lead 2 plus. Then over here, you're just going to have oxygen. I know that seems weird, but we'll resolve it ourselves if we follow the rules in a second. So what we have to do is we have to follow our rules. And I'm going to shrink this part up there, move this up here. Okay. Let's follow our rules. First thing, all right, what I'm going to have to do now is I'm going to have to balance my leads are balanced, so I have to balance my oxygens out by adding water. So I'm going to have to add 2 waters to this side to balance my oxygens, and I'm going to have to add 2 waters to this side to balance my oxygens. That means I have to add 4 hydrogen ions over here, and I'm going to have to add 4 hydrogen ions over here to balance out my hydrogens. So now my hydrogens, oxygens, and leads are all happy. I now need to take care of my charges. In my top equation, I have 4 plus on this side, 2 plus on this side. I have to bring my higher charge down to my lower, so I'm going to have to add 2 electrons over here. Then over here, I have a 0 on this side, and I have a 4 plus on the other side. So I'm going to have to add 4 electrons on this side. Now I have to add my 2 half reactions together in such a way that the electrons cancel out. I have 4 down there on the bottom, 2 up there on the top, so I'm going to multiply this through by 2. And that gives me 4 electrons, 8 hydrogens, 2 of that, 2 of that, and 4 waters. So now I add my 2 half reactions together. My electrons have canceled out and gone bye-bye. I come to 8 hydrogens here, 4 hydrogens there, so that gives a net balance of 4 positive over on this side. Then I've got 4 waters over here, 2 over here, so that gives me 2 waters over here. Then I've got 2 lead 4 oxides over here, 2 lead 2 pluses over here, and 1 oxygen and my waters. Alright, this would be good if we were in an acid. Are we in an acid? No. We're in a base, so we've got to add those hydroxides in. Because we're in the base, we've got to add those hydroxides. When I do that, I have to add them to both sides, and I have to add 4 of them, right? 1 for each hydrogen ion. So when I do that, I wind up with 4 waters on this side of my equation, plus my leads. Then I have 2 lead 2 pluses, plus my oxygen, plus my 2 waters, plus my 4 hydroxides. Oh wait, I've got 2 waters over here, 4 waters over here, so I can cancel out those 2 waters and reduce that 4 to a 2. And now I'm done, with one other exception. What about those chlorides I told you to ignore? We now drop them back in. I'm going to add 2 chlorides for every lead 2 that I have, and I'm going to have to do that to both sides of the equation. So I make my lead 2 back into lead 2 chloride. So I had to use 4 chlorides to do that, so I'm simply going to add 4 chlorides to this side of the equation. And 2 waters plus 2 lead oxides. And that's it. That's how you do it. And let me say, I think that is one of the most difficult problems you will encounter in the homework all day long. That's it.